Hello class, it's just me, Mr. Wee again. I'm going to continue off from where I left off on the first video, which is month 1, week 1 lesson. Should be section 1.2, composite functions. So you should have watched part 1, but we're going to go over part 2 now, which is a direct continuation of part 1. So you do need to watch part 1 to kind of understand what's going on. So again, we're going to go over f of x, which is equal to x squared minus 3. The g of x is going to be equal to square root of x, what is it, plus 2, okay? Last time we went over the g of f, which is the g of f of x, and what that looks like. I'm going to put dot, dot, dot. So I go back to the original video, maybe like fast forward towards the end, and see what kind of where we left off. And then today we're going to go over, or whatever, later in the day or wherever you are right now, or we're going to go over f of g, which is the f of g of x. So this time, it's as if you're taking your x value, your input value of x, putting it first through g. Then I think I remember saying that, I don't know what, actually I'm not even going to put output to confuse you. I'm just going to put some kind of output. And we know that output is synonymous, or pretty much the g of x, okay? Because we put x through g, so you're going to get the g of x as the output. And this time we're going to put it through f. So your final output is going to be you're taking the f of, technically, well, what was your output is now your input for going into f. So the f of g of x, okay? We're going to look at what that looks like. Give me 1 second. I'm going to adjust some notes really quick. Let's see. Yeah, f of x, this is the g of f of x. Sorry, I had to write some notes to myself too. Okay. So if you look at f of x, f of, technically, this is whatever goes in here is your input. When we put our input as x, we see that the input position is going to be squared, and then you subtract 3 from it. But in this case, f of g of x is equal to x squared, square root of x plus 2. It's going to be like saying the f of g of x, which is synonymous, or the equal to x plus 2, square root of x plus 2. That's going to look like this. Where my input position is, which is being squared minus 3, we're going to put in g of x, which is square root of x plus 2. So I'm going to put the square root of x plus 2. That's being squared, and you subtract 3 from it. Okay, I'd be okay with that, okay, but most mathematicians would like to see it, quote unquote, simplified. Okay, so what that would look like would be, this is now going to be x plus, let's see if I got this right here. Yep, just be x plus 2 minus 3, and then we're all fine and dandy. So we got x minus, sorry, this should be x minus 1. This is your final simplified version of the f of g of x, right? So there's a reason from the part 1 on that original video why I always like to look at the original, untainted, unedited, unsimplified, like quotes around simplified version of x, or like whatever f of g of x is. This is the simplified version, because if I graph this and I ask you what the domain is, what the range is, right, what would be your guess? Well, think about first the domain. Is there any inputs of x values that I can't put into this? Well, no. It looks like I could put in, my guess is all real numbers, right? That's just a guess. Don't write that down. And then the range, I would suppose, could be any number. I don't see any impossible numbers that might occur. So again, should be all real numbers if I look at x minus 1. But I say, for the sake of just being careful, let's graph this and see what happens. I bet most of you would say, I'm just going to see a linear line like x minus 1. Well, I don't disagree, but look what will happen. It's very interesting what will happen. Let's hide this kind of notation, or that little bar here. So, like I said, let's input the original unsimplified version of our composite function f of g of x, which is square root. You can put sqrt, that's how you initiate the square root, The Desmos will understand what that means. The Desmos, okay, x plus 2. We're going to close that parentheses. I'm going to put shift 6. Should give me this caret, okay? Again, shift, hold on to the shift button, and then 6. Press the number 6, and then you get the exponent. That's how you initiate that, okay? Then you're going to put 2, and then you're going to arrow over. I'm going to press the right arrow key once to get off of that exponent position. So you can try this out, -3. Look, it is aligned like we were thinking, but let's compare that to just the simplified version, which is x minus 1. Whoa, wait a minute. X minus 1 is a full continuous line. Now when I turn it off by pressing this green button, that means it's color-coded now. And if I do that means it's no longer graphed. It's the same thing. Let's overlap that one more time. That's x minus 1. Now let's take off x minus 1. But it's cut off. Why is that? Let's think about it. It stops right there. If you think about it, the domain is any real number above, greater than -2. So let's think about numbers on the x-axis. It starts from -2, and then it can go off into infinity, it looks like, okay? Like positive infinity to the right side. Whoops. The range looks like it's from -3. The range, all the y values, starts from -3 and goes up to infinity as well. So let's go ahead and write that down first and observe why. Like we can study why that is in just a second. So this is not the domain and this is not the range. The actual domain is going to be x is greater than, x is greater than, what did I say it was? -2. X is greater or equal to -2. And the range is going to be y is greater than or equal to -3. But why is that? So let's just take a look really quick. Let's go back again. So I thought this was a solution, but again, only look at this. You're going to get the shape of x minus 1, but with some extra little things added to it because the original version before it was simplified was actually the square root of x plus 2 squared minus 3. So let's put in a number that defies this domain. Let's go a number less than -2. You know what? I'm not going to do with -1. I'm going to go to, yeah, actually, let me see. Let's less than negative. Yeah, it has to be, I always forget on the number line, -2. That means a number less than that would be -3, -4. So all the numbers less than -2 are going to go to the left. So let's take the domain, an x value of, let's do the f of g of -2. What that's going to look like. Again, that's going to be input here. It's going to be -2 plus 2 minus 3. Oh, sorry. It has to be a number less than -2. It has to be -3. Okay. There we go. -3. Oh, I already see the problem. Do you guys see it? Those are -3 plus 2. That's going to be -1. Oh, there we go. Okay, so let's see what we got here. I know what you're thinking, but don't jump ahead. Don't think like that. Okay, it's order of operations, so it's whatever's in the parentheses first. Okay. I know you're thinking square root sign and square sign will cancel out, and then you get -1. I know we're used to doing that as a shortcut, but in PEMDAS, it is the order of operations. PEMDAS. This is calculus is where technicality and everything that you've learned previously does matter. What I mean by technicality is go by the order of operations first. Is the number real before you cancel out the square root sign and the squared sign? Does it exist in the real domain of numbers right now? Meaning -1 square root in this parentheses, does it exist? No, it does not. it will give me plus or minus I, which is not a real number. Again, I know what you're thinking. Square it, and it becomes a real number again, okay? But the fact that this has already begun, you cannot have this. So that does not belong in the domain. So any number that is less than -2 will not exist in the real plane of numbers, or you won't see it on the graph, okay? And for the range, if you're just wondering, it's just, if you plug in -2, that's what you're going to get, is a y value of -3, okay? So you're going to have y is equal to, or f of g of -2 would be square root of -2 plus 2 squared minus 3, which would just give me 0 squared minus 3. And as you can get to tell, that's just going to give me a y value of -3. And then pretty much from there, as my x value increases, okay, then all my y values would be greater than -3. So that's why I have that range. That's all. So you still don't believe me? Let's try -4 into the domain. Let's do f of g of -4, which I always forget this. What is it? It's going to be square root of -4 plus 2 squared minus 3. Again, that is the square root of -2 minus 3, which again is prohibited because this will give me a negative number, okay? And then that in PEMDAS will give me an imaginary number, pretty much, squared minus 3. And I know what you're thinking, imaginary number squared would just give me back the real number, but the fact that it existed for that brief second makes it so this is not a tangible real number that you can graph, okay? Otherwise, this, again, it brings it back to this whole argument of, wait, Mr. Wait, if it's simplified, x minus 1, I should just see a line. But the thing is, what you see as a graph is not x minus 1. It's x minus 1 with the added feature of, hey, there's some numbers that make this impossible at the very instant and very beginning when I put in the number, okay? All right, guys, that's all I have for you guys. So thank you guys very much for listening to me about composite functions. I think in the next set of videos, I'm going to kind of go through how to kind of graph on the TI-83. All right, guys, thank you guys so much for listening. You guys have a great day, and I'm going to stop the video.